Hey guys, how's it going over there? So, I'm sure probably a lot of you already went through this and there's no special time of the month. But in your calculus class or maths 2 class in particular, you probably come across differential equations, and these are actually one type of differential equations. This is actually the first special case of first order differential equations that we were going to look at. And this is called the linear first order differential equation, or LDE, linear differential equation. And these always take this kind of form: dy dx plus some function x multiplied to y equals another function x. So these are not like those separable differential equations where you could just throw dy on one side, dx on another, y on the left, x on the right, and then integrate both and solve it easily. No, this is a slightly more difficult one. And the reason why it's difficult is because, well, you need to know a quick and dirty method to get this right, and I'm going to show it to you. You also might have noticed I put other things on the whiteboard. I put ix, which is integrating factor. This, guys, trust me, this will be hell of important. You're gonna need to do this to solve these kind of problems, okay? And dy dx is also written different ways. For most cases, we write dy dx as y prime. So likewise, d2y over dx squared we write as y double prime, just for consistency's sake. Well, anyway, before we prove, actually, to be honest, we're not going to prove in this video. We're just going to quickly do it. I'm going to prove it at another time. Okay, so let's jump to an example and see how it's done. Okay, guys, see you in a second. Hey guys, so I rubbed out the board clean so I can show you this. So suppose we have an example: y prime equals xy minus x. Notice that it's not exactly in the form I told you earlier, but let's rearrange that form. And remember, dy dx is y prime. So I'm going to rewrite it into the linear differential form. So first things first, we put y prime on the left, which it already is, plus some function of x times y equals of another function of x. In this case, we have to subtract xy across. So we're going to have something like xy equals minus x. And therefore, px is minus x, qx is also minus x. Okay, yeah, that's the first bit done. Now, about the integrating factor, what do we do from here? Well, this is where we're going to use the integrating factor. Our integrating factor is defined as the exponential of the integral of px dx. And the reason why we're not going to put a constant here is because there's a proof which tells us that the constant is absorbed into the final equation. But don't worry about that. So let's evaluate this. What do we get? So first things first, we're going to get e minus integral of x dx, and this is just an easy one. This should just be x squared over 2. So it's going to be e minus x squared over 2. And don't worry about the plus e, not needed. Okay. At this stage, we can jump straight into the final solution, the final expression for y, which is, let me just rub this board clean. Alright guys, so let's finish off quickly, okay? So therefore, our solution is going to be yx, or just y, equals 1 over the integrating factor, so it would just be 1 over e minus x squared over 2, bracket, big integral, and now over here we're going to put qx times ix, okay? So qx times ix will be minus x e minus x squared over 2 dx, and of course, lovely plus c. And there we have it, guys. So all we do is integrate this part and we got our general solution. So guys, to evaluate this integral here in particular, well, this is not part of the video and I just want to show you how to obtain OD, but let's do it quickly since we're here. So recall, for integration methods, we could use partial or substitution. In this case, because we have an x squared here, we know that the derivative of an x squared involves an x, so you can actually use substitution, which will eliminate the x. Let's have a look. Suppose we let u equal minus x squared over 2, and hence, if we take the derivative, du, drop the 2 down, we're going to have minus x dx. Is that right? Yep, that's correct. We're going to get that. And if you notice, minus x dx, bang, goes right over there. So it cancels out. So Replacing this, we're going to have the solution yx equals, put this on top line, e x squared over 2, the integral of, so replacing this part, let me change color, minus x dx is gone as du, and e in this part is just u, so just eu du plus c. And replace integrating this completely, we're going to get x squared over 2, this would just be eu plus c. And replacing eu, we're going to have, oh, hold on. And there we have it, guys. Here is the solution. See you guys next time.